Y'all ready for this? I'm going to connect my favorite analogy, paddle in the water, with running mechanics and the different components of gliding, moving horizontal. Welcome back to Learn to Run. My name is Dr. Matt Minard, and I'm a physical therapist passionate about helping you run smarter, safer, and faster. So without further ado, let's get into this. Gliding with the paddle analogy. And what is the paddle analogy, you ask? It's correlating running and moving forward on land with you being in a canoe, on a paddleboard, in the water, where all you have is a paddle. I like this because it minimizes the variables. There's not many options when it comes to you in the water with a paddle. When it comes to running, there's different variables, different options, different joints. It gets more confusing. So that's why I like using this analogy, because I think it makes it a little bit more simplified and it can automatically apply this newer concept to something you already know and already understand. Where do you categorize this information into your brain when it comes to all the content? So today we're filling 3 of the 5 buckets: technique, VO2 max or oxygen demand, and injury or injury prevention. Said another way, today we're talking about efficient movement strategy, lower oxygen demand, and loading at the same pace but lower loading. And this will all make sense when it comes to efficiency. How can we get the job done, move forward, either with less effort, or can we keep the same effort, same energy expenditure, but move forward faster? These are the 3 buckets. Let's get a little bit more clear of a definition on gliding. As always, I like to think zoom out, big picture, not into the weeds quite yet. Imagine your body is just one unit, one rectangle. How do we move forward, minimizing the up and down and minimizing the braking or slowing? That's really what all this is. Gliding is 2 parts: leaning and leaving the ground, moving purely horizontal to maximize forward momentum or minimize braking, and forward propulsion, moving purely horizontal. So let's go back into simple shapes again. First, the leaning, where your center of mass is, where your balance point is in relationship to your base support or when you're grounded. When it comes to just standing still, they're both matched up. Our center of mass is directly over our base of support. Leaning is simply just manipulating or shifting my center of mass within the base of support. So that's step 1. That's the leaning. When it comes to running, ideally we're shifting, we're leaning our weight, our center of mass forward. Then, when it comes to that leaving the ground phase, the moment we become airborne, the moment that we leave the ground, the entire body is translating horizontal or forward and then down, not leaving the ground, continuing to move up and then forward and then down in that arcing or the bounding. And so that's why if we look over here at the icons of me, I'm 6 feet tall, roughly. If I'm standing in a room that has a ceiling height 6 feet tall, the entire time, I'm staying under that. The entire cycle, if I'm gliding appropriately by first leaning, shifting the weight forward, and then leaving the ground by pushing the ground purely backwards to move horizontal, we would stay under that threshold the entire time. So that's our definition. That's gliding, the 2 L's, leaning and leaving. So now we're going to correlate that to the paddle analogy or paddle boarding. It's a little bit more closely related. I'm standing up, got a paddle. 2 parts, the leaning and the leaving. So here I'm standing still. I'm vertical and upright. I have a PVC pipe parallel with my body in line with the plumb line of gravity. When I'm leaning, if I'm doing it appropriately, if I'm setting myself up for success to propel myself forward, this is ideally what it should look like. Hinging at the ankle, the hankle. Versus here, why do I do this? Am I leaning? Yes, but what am I not doing? I'm not leaning from the ankles, and the reason for it is it's all protective mechanism. Imagine now that this is the water and you're on a raft. If I had you do this out on the water, you wouldn't do that, right? You'd fall forward, you'd fall in the water. Subconsciously, to prevent yourself from falling, this is what you would do. It's all a balancing act. As your shoulders would go forward, your hips would simultaneously come back to keep your weight centered. And that's why here, yes, we're leaning, but we're not shifting the center of mass forward. And why is that important? When it comes to running or walking, no matter what, there's going to be braking forces that occur. We can't land directly underneath us unless we're just jumping up and down and staying in place. So there's always some braking. The goal is minimize. How much can we minimize the braking? So if we do this correctly, if we shift our entire weight forward, what we do is we set ourselves up for success. It's all about how close can we get where we land and where our center of mass is. So by us shifting the weight forward, what we're actually doing is we're shifting our center mass forward. We're setting ourselves up so that when we land, we're already closer to our center of mass. So we're minimizing braking. Versus if you see someone running like this, hinging forward, hinging at the hips, shoulders out in front, they're still going to be braking more because they're landing and loading in front. Their center of mass is still back. The other option is not leaning at all. A lot of people won't lean. They'll have their body be straight vertical and they're trying to move forward, keeping their weight back, which will have the similar effect, landing and loading in front and subsequently braking. So it's really hard to talk about propulsion, the engine, with also including the leaning. So that's why when I teach this, I always teach the leaning first, because you can't propel efficiently without also leaning. They go hand in hand. And that's why gliding is two parts. As much as I like it to be just one, try to simplify as much as possible, but it's two components. So I'm going to show an example of me pushing the water back, which is going to move us forward, right? And I'm going to show the difference of one, where's the center of mass? And two, how much are we pushing to get that forward propulsion? So first with the leaning, what you'll notice in this first video is when I'm pushing, this is also representative of that forward lean. Versus here, if we have kind of a top-down approach where I'm holding that, see how when I end, it's more vertical? So back to the other example, the first one, I was leaning forward, then pushing back. Here, more vertical and upright, not leaning and then trying to push back. What do we notice? How much actual backwards propulsion do we get? So if we look here, how much is the paddle behind us? Versus here, how much is the paddle behind us? This is where we get our propulsion. This is where we get our power, pushing back to move forward. So a lot of times you'll hear people, they kind of disregard this phase. They don't talk about it. This is where the magic happens. Here, if I'm focusing on, or if someone's cueing, pick your feet up, lift your feet up, we're totally disregarding that pushing back phase. They're pushing down, which is also going to cause them to go up, and they're just merely picking their feet up, which just will bring us into our next example of showing the leaving the ground. So here, this is after the phase, after ideally we push all the way back. So here in both examples, it's the correct propulsion, pushing back, but then what happens next? Imagine just like you were out on the water, what would you do? Ideally, after you push back, you glide the paddle forward and repeat. Why would we pick the paddle all the way up out of the water? So when people will say, pick your feet up, lift your feet up, this upwards is what they're referring to. So do we really need to focus on that? On a level, flat surface, do we really need to focus on that? Because what is this going to do? By introducing up, by pulling up, we're introducing vertical movement into the system. Gliding is not vertical. Here's an example of what it would look like. Let's correlate it. And then we'll see the whole running cycle. Right leg, ideally after we push back, The leg is just passively coming forward. I'm not actively trying to lift. All that's just naturally happening. And yes, the faster that we go, we will see the leg go further back. Just like if I said, hey, go faster in the water, you push the paddle back further and it would naturally come up higher. Versus here, where I'm gonna lift and pick up the paddle going forward. Here's the other reality. This is happening on both sides, right leg, left leg. It's happening so fast, at such a fast rate, we can't focus on and think about more than one thing. So not even thinking of right leg pushback, left leg pushback, it's happening too quickly. All you're thinking about is your relationship with the ground. Every time you come in contact with the ground, doesn't matter which part of your body, all you're thinking of is pushing back. So now we're gonna do a top down of pushing back versus the pulling up and the bounding. Top-down approach. First, let's look at the difference of the head height. Next, the arms. This is why I say wrist below the elbows, sawing forward and back, not up and down. Notice how my heels stay under my knees, not going up and lifting. Let's watch that one more time because it's so important. Up and down, bonking the head, picking the foot up, lifting the foot up, arms axing up and down, feet coming up, bounding towards the butt. So here's the other reality. If you introduce that into the system, everything else follows suit. You're not going to pick and lift your feet up and not also have the arms matching and syncing up with the legs and the head going up and down. It all comes into play. Think about the entire system. Let's tie this energy expenditure or running economy back to this analogy of the marathon mortgage. Ideally, your payment, what you're exerting, your energy, just like with a mortgage, you're spending, we just want as much of that to go towards paying on the principal as possible. Principal with the marathon is moving forward versus the mortgage is the principal. Anything that we're exerting or spending that's not going towards the principal, it's going towards the interest. So our goal is, can we get higher amounts of payment on the principal and as low as possible payments on the interest? Here, this example, the interest is the up, it's the vertical. So here's where we can all win. Me as a physical therapist, not wanting you to get injured and you wanting to run faster. It's all about reallocating the resources. Our running economy, how much you're spending. We can either spend less and keep the same speed. Why is that? Because we're not wasting as much energy. We're lowering the interest. So we can either keep the same amount of effort and run faster and reallocate those resources to now running faster, or keep the same speed and merely less effort. This tends to be safer, less overall force. Here, we're running faster because you're keeping the same amount of exertion, but you're reallocating it from the interest towards paying on the principal. So I hope that was helpful. I hope that tied a lot of things together. Here's the Learn to Run ecosystem. Keep following along on YouTube and Instagram for free information, and a lot of you, this will be all that you need. If you're looking for a little bit more, the Learn to Run Club has everything in one. Training plans, the 3 different processes of running mechanics, which I'll go over into in another post, where it feels like I'm there with you. The military training plans, if you're running for military, Navy, Army, Air Force, Marines, and then if you're a clinician or running coach learning to implement the system, I've got you either way. Questions, comments, concerns, please let me know, and I'll see you next time.